Hello and welcome to this Icarus presentation. My name is Katrina Dupoyer and I work for the engineering consultancy Research Driven Solutions, who are based in Dublin, Ireland. The topic that I will be presenting today is resilience, resilience assessments, and climate change adaptation. Icarus is a CEDAR-funded project with the primary objective of improving the uptake of climate change adaptation in the decision-making processes of road authorities. In this project, we follow 6 stages as shown on the slide below. Firstly, we have framing and business as usual stages. Then we have adaptation options, looking at what could we do, what can we implement. Then we have the decision stage where we try to decide what we can do. We then move on to implementing our adaptation options. And the final stage is the monitoring and evaluation stage, looking at what we learned and how have we progressed. In this video, we will focus on the first 2 stages, which are framing and business as usual, where we will look at ways to assess how we do things now. In this video, I will introduce the concept of resilience and ways to assess infrastructure resilience. I will give a brief overview of the resilience impact score calculation, which was developed for this project. And I will show how resilience may be used to provide input in decision making and assessment of possible adaptation strategies. The definition we have chosen to use for the Icarus project is the IPCC definition, which is as follows. The capacity of social, economic, and ecosystems to cope with a hazardous event or trend or disturbance, responding or reorganizing in ways that maintain their essential function, identity, and structure, as well as biodiversity in the case of ecosystems, while also maintaining the capacity for adaptation, learning, and transformation. Let's look at that in a little more detail. It's important to note here that this definition highlights the ability of a system to maintain its essential function while also maintaining capacity for adaptation, learning, and transformation. So resilience is basically defined as the ability of a system, social, economic, or physical, to maintain service if a disruptive event occurs, but also have the potential to adapt to future events. And this is what gives it a temporal aspect. So in Icarus, we've developed a way to calculate a relative value of resilience impact called the resilience impact score. This is determined by calculating the area of the resilience triangle as shown in the graph below, and it's adapted from the resilience triangle developed by Tierney and Bruno. This way will allow infrastructure managers to determine which climate impact drivers will have the biggest impact on their infrastructure. So let's take a look at this in operation. How does this calculation work? So first we'll start with the type of asset that we're interested in and the climate impact driver and the event. And these are just to provide information on what you are assessing. So in this case, in the first example here, I want to assess the impact of a cold spell on my road infrastructure, and this is an extreme event. In my theoretical event here, my cold spell, it's going to last for a duration of greater than 1 day, so I've given it a score of 3. And the minimum service level is going to be restored in less than a week. So we've less than a week's disruption here, which results in a score of 2. In the next column, we choose the factors affecting functionality. So I've decided that there's only a small amount of damage, so we give it a score of 1, but because it's a cold spell, it's going to affect my entire network, which gives it a score of 3. When I do my calculation, multiply my time by my factors affecting functionality, we end up with a score of 7.5. The next example is for a landslide. Okay, so again, we have a similar calculation where my event duration is instant. It's over quite quickly. However, it takes a little bit longer to recover from it. It takes less than a month. There is a medium amount of damage, but it's at an object level, so it's localized, and this results in a small score of 3. Finally, we have an example of a tropical cyclone which affects my entire road network. This is an extreme event. Now, the event lasts less than a day, so I give it a score of 2. It takes greater than a month to restore full service, or for minimum service to be restored. So that results in a score of 4 here. It has caused quite large damage at a widespread level, at multimodal level, and so that gives us a score of 36. So we end up with a loss of resilience of 36 for the tropical cyclone, compared to just 3 for the landslide and 7.5 for the cold spell. So in this way, you can compare the impact of different climate impact drivers on your infrastructure and determine how they would affect the resilience in each case. It is important to note that the resilience impact score is a relative value and not an absolute value, but it can be used to help determine which climate impact factors are going to affect our infrastructure the most. So when can we use it? So it can be used to identify high impact climate events which cause disruption to your network. It can also be used to compare impacts of different events on assets and help in decision-making processes. If higher scores are achieved, then adaptation options should be considered to increase asset resilience. Note that a review of KPIs and/or impact chains may also be useful in determining the impact an event could have on an asset. Thank you for watching our video. I hope it has helped you to understand climate change adaptation a little more and will help you to measure the resilience of your assets and identify which assets or which climate impact drivers will be most critical for your network or your organization. If you would like more information, please look for the longer version of this video, and you can find more information on our website at the link below or by scanning the QR code. If you go to the resources section of the website, you can find deliverables 2.1 and 3.1, which are related to the content of this video. Thank you.